Now, this video discusses about the projectile motion where the object is released from the top horizontally to the ground. That is said to be the top horizontal released ground case of the projectile motion. So what is that? Let's say if we have, let's say this is a building. And let's say this is a typical building. And let's say it is a building of, let's say, a height given as h. Should be that. And let's say we have an object released from the top of the building horizontally. And now after some time the object happens to now descending down to the ground. Let's say that is the case. And now as the object will be striking the ground, or as the object will be hitting the ground, it will hit the ground with the two components of velocities. And for instance, the object will have the velocity along x that occurred as v actually fx. Should be that is vfx. That means the final velocity along x. And it will have another component of the velocity along y that occurred as vfy. And now let's consider the velocity in which the object has been released with from the top of the building. And that velocity is said to be the launch velocity. And basically, let's say we should have it as v naught. So this is the launch velocity from the top of the building in which the object has been released horizontally in that way. So now you should have to understand that from the top of the building, what is the initial velocity along x? Now the initial velocity along x, which is given as v naught x, is equal to the launch velocity, which is given as v naught. And because this velocity, the object has been horizontally released, therefore the x component of the initial velocity along x is the same as the launch velocity. And what is the initial velocity along y? We'll have it as L, because you know this launch velocity has no component along y axis, hence the launch velocity along y will be given as L. So it should be that. So at the end of the day, let's think of analyzing the motion of the object in actually components. Should be in both the axes separately. So let's start with the analysis of the motion of the object in our x-axis. So as we already talked about that the projectile motion, the analysis is done independently. So let's start with the analysis along x-axis. So it should be along x-axis. Should be along x-axis. Let's analyze the motion along x. So how should you have to understand about the analysis along x? Now the first thing you have to understand is that there is no acceleration due to the gravity in x-axis, because acceleration for actually because the gravitation force is not felt along x-axis. Therefore, acceleration due to the gravity is L. And because the acceleration is L, it means the object along x-axis is said to be moving at a constant speed. Therefore, the launch should be the initial velocity along x is the same as the final velocity along x, and which is corresponds to the given as the launch velocity. So which means as the object will be striking the ground, the final velocity along x will be the same as the launch velocity. Should be that. And now in that way, and how about the distance in which the object has to travel along x from the point of release to where the object is going to strike the ground? And now the distance said to be the horizontal distance. You should have that on. So now the horizontal distance given as hd. Horizontal distance given as hd is given as given as initial velocity along x times the time which is said to be a total time, and this is the same as should be the final velocity along x times the total time, which is the same as should be the launch velocity times the total time. You start to understand that the initial velocity along x is the same as the final velocity along x because the object is moving at a constant speed along x-axis. Therefore, at the end of the day, the horizontal distance corresponds to have it as the launch velocity times the time. You start to understand that this time is said to be the total time for the whole entire journey. So the time in which the object has to travel along x-axis from the point of release to the point in which the object will be striking the ground. Along x-axis and the y-axis, time remains the same. Therefore, this time corresponds to the time for the whole entire journey. So it should be that. So that's how you start to understand about the analysis of the motion of this object in the x-axis. So acceleration due to the gravity is L because the gravitational force is not felt. And basically launch velocity is the same as the initial velocity along x and also the same as the final velocity along x. It should be that. And also in the same case, the horizontal distance is given as the launch velocity times the total time. Like that. And how about the analysis along y-axis? How should we be able to analyze the motion along y-axis if that is the case? Now the analysis along x-axis, y-axis has to be in this way. The initial velocity should be along y. Acceleration due to the gravity along y-axis is felt, and that is given as the negative 9.81 meters per second square. And now the initial velocity along y is given as L because the object has been said to be the horizontal released. Therefore, the launch velocity is horizontal. It has no component along y-axis. Hence, the initial velocity along y is given as L. And how should you have the final velocity along y-axis? So the final velocity along y-axis, which is given as v of x, is calculated using the formula given as the final velocity is equal acceleration times time plus the initial velocity. Now this final velocity is given as vfy, that is the final velocity along y-axis should be y. That will be given as vfy, which is equal to this acceleration is now acceleration due to gravity, and this time is the time for the whole entire journey, which is capital D. And this initial velocity is the initial velocity along y, that are called as v naught y, and this corresponds to have it as vfy is equal to negative gt. So this is the formula we use to have the final velocity as the object will be striking the ground along y-axis. It should be that. Now, how about the velocity? How about the height of the building? So how can you have the height of the building? And that which is given as this case. Now the height of the building corresponds to have it as the displacement of the whole journey. And the height of the building is given as from the displacement formula, which is the displacement is equal to ut plus half ad square in this side. Now this displacement corresponds to the height of the building, which is given as h. And now this initial velocity is the initial velocity along y, which is given as v naught y. And this time is the total time, that occurred as capital T minus half gt total square. So this is the formula that we use to have the height of the building in case we have the total time and also the initial velocity along y-axis. And sometimes we can use the same formula to have, let's say, the total time if we have the height of the building, of which when we'll be substituting the height of the building will be given as the negative, because at the end of the day you have to understand that the displacement of this kind of the projectile motion is given as the negative height of the building. So basically, as you be substituting the height of the building, you should have to substitute that as a negative. So this is how you should have to understand about the principles behind the actually top horizontally released ground case of the projectile motion. Now, how should you have the magnitude of the landing speed? How should you have the magnitude of the landing speed? So we understand that the object, as it will be striking the ground, it will have the two components of the velocities. So have the final velocity along x as well as the y. So how should you have the magnitude of these two components of the velocities? So the magnitude is said to be the landing speed. That is given as, should be the square root of vfx square and plus vfy square. So that is the formula we use to have. That is the formula we use to have the magnitude of the landing speed as the object is striking the ground. And how about the direction? The direction is given as this angle theta. And how should you have the direction? We use the concept of the vectors as well. And thus you should have the direction being given as angle theta is equal to the tan inverse of should be vfy divided by vfx. So that's how you start to understand about the analysis of this kind of the projectile motion, which is said to be the top horizontally released ground case, where the object is released from the top of the building. So let's see some of the typical questions and appreciate on how we can have this. Let's say we have this question. A projectile is thrown from the top of a building with a horizontal velocity of 15 meters per second. Now the projectile lands on the street at 5 meters from the base of the building. How high is the building? Now this is a typical projectile motion, which is said to be the top horizontally released ground case. So you may think of having the sketch of the situation. Let's say this is the height of the building. And what is the height? So we're looking for the height of the building, which is given as h. But now the object has been horizontally raised, then gate lands on the position actually on the ground. And I wish to understand that at the end of the day, this is the horizontal distance that we are being given it as should be 85 meters. And this is the base of the building. Should be 85 meters. And we have the launch velocity, which is given as v0. We have it as 15 meters per second. And for that case, now we should have to understand that as the object will be striking the ground, it will have the two components of the velocities. We'll have the final velocity along x. We also have the initial velocity along x. It should be the final velocity along y. It should be that. Now the question says that we should have the height of the building, and of which we should also have to calculate the landing speed as well as the direction. That would just be some added questions, although they are not part of the question here. But now, how should you have the height of the building? The formula for the height of the building is given as height of the building is equal to the initial velocity along y times the total time minus half GD square. Now for that case, initial velocity along y is given as 0, and since the object has been horizontally released, and basically it means the whole of this one is 0, then we have it as negative half. Now we have the acceleration due to the gravity, which is 9.81, and that times. No, we don't know what is the total time, and of course we're looking for the height of the building. Should be that. And now what is 9.81 divided by 2? 9.81 divided by 2, what you can have is should be given as the height being given as 4.9 should be 1 t square. Let's say this is said to be the equation 1. What we do not have is the total time. But how should you have the total time if that is the case? Now the total time will be obtained from the formula of the horizontal distance. The horizontal distance, which is hd, is given as the launch velocity times the total time. And the horizontal distance is given as 85 meters. And the launch velocity is given as 15 meters per second. And the times the d total. So in that case, what you can have is, should be the d total being given as, should be 85 meters, and that divided by 15 meters per second. Now the meters will cancel, have 85 should be 85 divided by 15, and now that corresponds to have it as 5.7. Now that is the total time, which is given as 5.7. Now this will be substituted into this, and I'll be able to have the height of the building. And now we should have that on as, that should be the height is given as, and by the way, here it was supposed to be negative, should be negative here. It should be that. So now for this case, the height is given as negative 4.91 times, what is the term, 5.7 to the power 2. And how should you have that? The times 4.91, that is given as, should be a negative 157 point, should be 7 meters. So that is the height of the building. And why negative? Because that's the displacement. So basically this case of the projectile motion, displacement is given as the negative height of the, actually should be the negative of the height of the building. So that's how you should have to understand that case of the question. And the other question says we should have to calculate the actually landing speed as well as the direction. So how should you have the landing speed as well as the direction if that is the case? So now the landing speed is given as, and by the way, let me keep the t total here, so which is the total time. So total time is given as 5.7 seconds. Should have that one. So how should you have the landing speed? So now the formula for the landing speed is given as, should be the square root of vf x square and then plus vfy square. And what is vfx? Vfx is given as the launch velocity, which is given as 15 meters per second. How about vfy? So vfy is given as, should be negative g d total, that is equal to negative 9.81. and what is the total time? We have it as 5.7. now have it in meters per second. Now you can have to, what is should be negative 9.81 the times 5.7, and that corresponds to have it as the final velocity along y being given as 55.92 meters per second. It should be negative there. So that's the final velocity along y-axis as the object will be striking the ground. And now for this case, the landing speed will be given as, now just have to substitute this. That's to have it as 15 to the power 2 in the plus negative 55.92 to the power 2 should be that. And from there you can be able to have the magnitude. And how about the direction? On the case of the direction, we'll have it as the tan inverse of, so have the tan inverse of that of VFY. What is VFY? We have it as, it should be, what is the VFY? We have it as negative 55.92. Divided by what is VFX? We have it as a 15. It should be that. And you'll be able to have the angle there. And the angle will be negative because it is below the positive x-axis. You basically have it as a negative unless otherwise. But that's how you should have to understand about how that question can be approached. Now let's say we have this kind of equation. A bulb is dropped from an airplane in a traveling, should be an airplane in a level flight at a velocity of, should be 970 kilometers. And the altitude of the aircraft is should be that. At what horizontal distance from the initial position of the aircraft would the bulb has to land? So this is a typical, also a case of the projectile motion, where we have, let's say this is airplane. Let's say this is a typical airplane, should be that. Now for that case, it is moving at actually a constant speed, that is a horizontal speed of, should be given as 970 kilometers per hour, should be that. And now the object has been released from the actual airplane, and it should be that. And the distance from the ground level up to where the airplane is should be somewhere about, given as the height, which is given as 2,000 meters, should be that. And now a bulb has to land on the ground, should be that. Now the question says that at what horizontal distance from the initial position of the aircraft will the bulb land? So we are looking for the horizontal distance, which is HT. And the horizontal distance is given as the actually launch velocity times the total time, of which this is the launch velocity V0, which is given as that. That is the launch velocity, and we have the height of the building in that way. So how should you have the horizontal velocity? So for this case, what we do not have is the total time, but now the total time will be obtained from the height of the building, and of which the height of the building is given as, should be given as negative half g t total square, as we have talked about it, that this kind of a projectile motion, initial velocity along is given as, so hence we'll have this formula for the height. And now what we have is that we have it as, now what is the height of the building? We'll have to substitute that one as a negative, because that corresponds to the displacement, that is negative 2,000, which is equal to negative half, and acceleration due to the gravity, let me just have to have it as, should be negative 4.91 t total. Now for that case, we can have is this negative will cancel. We'll have it as now a t total being given as the square is equal 2,000 divided by 4.91. So what is 2,000 divided by 4.99? Should be 4.91. That corresponds to have it as, should be t total square is equal to 407.3, and we have to introduce a square both sides. What you can have is total time is equal, and what is the square of that? And what is the square of that one? We have it as a 20 point, let's say 2 seconds. So that is the total time, and of which you have to substitute it here, and the launch velocity is the same as this one, that we can be able to have the horizontal distance, but this has to be given in meters per second as well. So you should have to convert 970 kilometers has to be in meters. We should have to convert 1 hour has to be in seconds. Then I should have to divide by 2 in order to have, you should have to divide the 2 in order to have the launch velocity in meters per second. So you observe that the launch velocity in meters per second will have it as 970. What is a kilo? That is 1000. So which means that's times 10 to the power positive 3 meters. Divided by what is 1 hour in seconds, we have it as 3600 seconds. Then I should have to divide by 2. You should have to divide the 2 in order to have meters per second. So just have to divide the 2 numbers and have it in meters per second. So in case you need the full detailed structure about how to convert the units the way they are, you just have to refer to my video playlist about and check unit C conversions by GB Analytical School of Science. You come across all these things in case you may need the more stuffs about that. Otherwise, that's how it has to be. And also, let's consider this kind of a question. A cannon is placed on a hill 20 meters above the ground level. Let's say this is a typical hill. Let's say this is a typical hill. We should have. Let's say this is a typical hill. Let's say it is about 20 meters above the ground level. That is the height, which is 20 meters. Should be that. And now a shell is fired horizontally. Now it means the object has been fired horizontally. And with the launch velocity, okay, that's v naught, which is equal to 300 meters per second. Let's say we have that kind of a case. Should be 300 meters per second, like that. 300 meters per second, like that. Now, at what horizontal distance from the cannon will the shell run? Now, for this case, what happens is that the object now will have to get back on the ground. It will have two components of the velocity. It will have Vfx and will have Vfy. And this is now the horizontal distance from the base of the hill. Should be that. And now the question is that at what horizontal distance from the cannon will the shell run? We are looking for the horizontal distance, which is given as v naught times the total time. Of course, we have the launch velocity, but what we do not have is the total time, of which you have the total time from the forming of the height of the building, as you already know. So try to have that one. Now the other question says that how long will this actually take? We're looking for the total time. So of which you have already actually calculated that one in the first part of the question. So you just have to say, the total time will be given as the one you have calculated in the first part of the question. And now what will be the shell's velocity as it strikes the ground? So we are looking for the actual landing speed as well as the direction, of which you know what it means there. So that's how you start to understand about this case of the projectile motion, where the object is released from the top of a building horizontally to the ground. That is actually top horizontally is the ground case, where the object is released from the top of the building to the ground. This is the height of the building, and this is the horizontal distance given as hd, which is given as horizontal, actually a launch velocity times the d rotor. And we have two components of the landing speed. We have Vfx, and this is Vfy. We can have the landing speed, which is given as the magnitude. Landing speed, which is given as the magnitude of, should be Vfx square plus Vfy square, and the direction, which is this angle theta, will be given as the tan inverse of, should be Vfy of Vfx, and it should be that. And how should you have the final velocity along y? We'll have it as Vfy is equal, should be negative gt total, because the initial velocity along y basically it's 0 here, therefore just have that as that. And the final velocity along x should be Vfx. Vfx is the same as the launch velocity, so should be that. And the height of the building is calculated from the formula. Height is equal, initial velocity along y, of which is 0, therefore we just have to have it as negative, half g d dot square, have it as that. So that's how you start to understand about the formula analysis of this case of a projectile motion, which is a top horizontal realistic ground case. Of course, apart from this case of the projectile motion, we also have what we call it as the ground up back to ground. We also have what we call it as the top up angle ground case, and there are some others that for you, and that if you may wish to have more information about this, just have to check through my video playlist. Just have to check GB Analytical School of Science, ground up back to ground case of the projectile motion. We have several cases of the projectile motion that you may wish, and at some point in time I may post the links in the comment section below. Just have to go through and check. You come across all those things. Thank you.